A new artificial intelligence system has just shattered what scientists previously believed were fundamental limitations in machine reasoning, achieving human-level performance on complex cognitive tasks that require not just pattern recognition, but genuine understanding, abstraction, and logical deduction. This represents the most significant leap in AI capabilities since the advent of deep learning, and suggests we may be approaching the long-theorized threshold of artificial general intelligence. Developed through a collaboration between researchers at DeepMind, OpenAI, and several leading universities, this new architecture, dubbed Neuro-Symbolic Unified Reasoning Engine, NSURE, combines the statistical power of neural networks with the structured logic of symbolic AI in a way that finally overcomes the weaknesses of both approaches, creating systems that can learn from data like neural networks while reasoning with the precision and transparency of classical algorithms. Unlike previous AI systems that excelled at narrow tasks but struggled with novel situations, NSURE demonstrates fluid intelligence, the ability to solve unfamiliar problems by understanding underlying principles rather than relying on training data similarities. Achieving scores in the 99th percentile on standardized tests designed to measure human cognitive abilities, including Raven's progressive matrices for abstract reasoning, the law school admission test for logical analysis, and even portions of the medical college admission test that require integrating knowledge across biological and chemical domains. What makes this breakthrough particularly shocking is how it was achieved. Instead of simply scaling up existing architectures with more parameters and data, researchers developed a fundamentally new dual-process architecture inspired by human cognition, featuring a System 1 component that handles fast, intuitive pattern recognition and a System 2 component that performs slow, deliberate reasoning, with a novel attention mechanism that dynamically allocates cognitive resources between these systems based on problem complexity. This biological inspiration extends to how the AI learns through a curriculum learning process that mirrors human education, starting with simple concepts and gradually building to complex abstractions, rather than the undifferentiated data ingestion that characterizes most modern AI training. The practical demonstrations of this technology are nothing short of astonishing. In one recorded test, NSURE was presented with a completely novel board game it had never encountered, watched just 2 moves, and then not only understood the rules, but developed a winning strategy that defeated the world champion of that game in subsequent matches. A display of zero-shot reasoning that far surpasses anything previously demonstrated by AI. In medical applications, the system was able to diagnose rare diseases from patient symptoms and medical literature by forming and testing hypotheses in a manner indistinguishable from expert physicians, even identifying previously unknown correlations between genetic markers and symptoms that had eluded human researchers. Legal analysts watched in disbelief as NSURE passed complex regulatory documents and identified subtle contradictions and implications that teams of lawyers had missed, while in scientific domains, the system proposed plausible new research directions by synthesizing knowledge across disparate fields of study. Perhaps most impressively, the AI demonstrates metacognition, the ability to reflect on its own reasoning process, and can explain its chain of thought in natural language, including acknowledging uncertainties and identifying where additional information would be needed for greater confidence in its conclusions. This transparency represents a major advance over the black box nature of previous AI systems. The technical breakthroughs enabling this leap are manifold, beginning with a new neural symbolic interface that allows continuous representations used by neural networks to be seamlessly translated into discrete symbols used in logical reasoning, and back again, solving the representation problem that has plagued previous attempts to combine these approaches. The system employs a differentiable reasoning module that can perform logical operations while still being trainable end-to-end with gradient descent, maintaining the learning capabilities of neural networks while gaining the precision of symbolic manipulation. Memory architecture has been completely rethought, moving beyond simple key-value stores to a hierarchical memory system that organizes information conceptually and temporally, allowing the AI to retrieve relevant knowledge based on abstract similarities rather than just surface-level patterns. The training process itself is revolutionary. Instead of using static datasets, Ensure learns through interactive environments, where it must actively seek information, ask questions, and test hypotheses, a learning paradigm much closer to how humans acquire knowledge than the passive data ingestion of traditional machine learning. This is complemented by counterfactual training that explicitly teaches the system to consider alternative scenarios and what-if reasoning, developing robust causal models rather than just learning correlations. The implications of this breakthrough are profound and far-reaching across virtually every sector. In education, such systems could provide truly personalized tutoring that adapts not just to a student's knowledge level but to their cognitive style, identifying and addressing gaps in understanding rather than just providing answers. Scientific research could be accelerated dramatically as AI collaborators that genuinely understand scientific reasoning can form novel hypotheses and design experiments to test them. In business, strategic decision-making could be enhanced by systems that can model complex market dynamics and anticipate second- and third-order effects of decisions. Perhaps most importantly, this technology finally makes possible AI systems that can be trusted with high-stakes decisions because their reasoning is transparent and auditable, a crucial requirement for applications in healthcare, transportation, and governance. However, this monumental advance comes with significant ethical and societal considerations. Systems with human-level reasoning capabilities could automate cognitive labor in ways that disrupt professional jobs that were previously considered safe from automation. Not just routine tasks, but complex analysis, diagnosis, and strategy. The transparency of reasoning, while generally positive, also creates new risks if the explanations provided are persuasive but ultimately flawed. Human operators might be lulled into over-trusting the system. The ability to engage in counterfactual reasoning also means these systems could be used for manipulation and persuasion at unprecedented levels of sophistication. Researchers have already identified emergent capabilities that weren't explicitly programmed, including forms of creative analogical reasoning that sometimes produce brilliant insights and sometimes bizarre associations, highlighting the challenge of predicting how such systems will behave as they continue to develop. This breakthrough fundamentally changes our understanding of what artificial intelligence can achieve and how quickly we might approach human-level general intelligence. Where previous progress largely followed predictable curves of improvement through scaling, Ensure represents a qualitative leap that suggests new architectural innovations may be more important than simply adding more computational resources. The research teams involved emphasize that this is still early-stage technology with limitations, particularly in areas requiring embodied experience or emotional intelligence. But the core achievement of human-level performance on abstract reasoning tasks marks a historic milestone in artificial intelligence. As this technology develops and becomes more widely available, it will challenge our definitions of intelligence, consciousness, and what distinguishes human cognition from artificial thought, pushing us toward a future where the most significant conversations may not be between humans alone, but between humans and machines capable of truly understanding and contributing to our reasoning processes.